worded it wrong.
Thank you. Thank you. Thank you. All right, so can I grab everyone's attention? So I know that some of us aren't finished typing about A, but that's okay. What we would want to do at this point is look at each person's responses and discuss these things, and then that way you have something to write down specifically in your graphic organizer from the textbook. So, first off, what section should we be writing about on the graphic organizer when we change that value of A? So yes, we need to be looking at vertex form, but I'm talking about the characteristic. Okay, so x-intercept, any other ideas? The vertex? Maybe concavity? Alright, so let's look at y'all's responses. Alright, so the value or rate of change starts at the negative interval and starts increasing. Okay, so we see some ideas about increasing versus decreasing. So what about A? Does A change the wideness of the parabola? Uh-oh, let's look at this note. Did the vertex move when you changed A? No? So should we be writing anything under vertex?
Yes.
If the vertex doesn't change, A doesn't affect the vertex, I'm not looking there, right? So we shouldn't write anything about vertex, okay? Moving A can change the parabola to a concave up or a concave down, and changes the parabola's linear rate of change. Now, I want to pause for a second, and I want to look at this. Are you moving A? Thinking about that language. So let's go back now. I want to look at this page. Alright, let's look at page 2 really quickly.
Adjusting.
I know, what are you probably referring to when you say moving A? You're moving the slider, but A is a point. Is it a point? It's a value or a number. We want to notice that A is a value or a number. So we wouldn't want to say when you're moving A. We would want to talk about when A is maybe increase, decrease, but it's up here when A is positive versus negative, right? Remember, this should be guiding our thinking. We should be thinking about this information up here. So let's look at some more of these. The concavity changes. The parabola gets wider when x is above 1 and smaller under 1. The parabola flips when the value of A is less than 1 and it's greater than 1. So we need to investigate these claims a little bit more. Let's look at this. So right here, is the concavity flipping when A is less than 1?
No.
No. When does the concavity change? Okay, so actually let's look at 0. When it's at 0, we have what kind of function? A linear function, a line, right? But when A is less than 0, which is when it is a negative. Ah, there we go. Okay, so we want to notice these things. Now I want to pause because quite a few of you from what I saw talked about the fact that it's a line when A is 0. Does anybody have a guess why? So if A is 0, what's 0 times anything?
0.
So I'm left with 0 plus k, and what's 0 plus k? Oh yeah, because that's that additive identity. Notice how there's no variable x left? That's why it's, and so really there's no x squared. That's why it's becoming linear. Does that make sense, at least for there? Well, if it had been like y equals, I don't know, 2x minus k, that would be the equation of a line, right? So if it's y just equals, I guess I should just make this up, say 5. Wouldn't that be an equation or a graph where every y value is 5? So it's a line. The idea being that the x squared is now gone, and we need that x squared for it to be quadratic. And that was because A was 0. But what we want to focus on, so let's work on our language here. Remember I asked you to focus on when A is positive or negative. When A is positive or greater than, is greater than 1 the only time it's positive?
0.
Ah, when, and this is what which section of the graphic organizer are we looking at? Concavity, right? We talked about concavity here. When A is positive,
Will it
Right.
always be A?
A is greater than 0, huh?
Will it always be A?
So far. We're going to look at more in a second, but I mean, what we know for sure, are you talking about like, do we always use the letter A?
Yeah.
Yes. We'll always use that letter A. Okay? So when A is positive, A is greater than 0, the parabola is what?
Concave up.
There we go. That's what we want to notice. Versus when A is negative, that's that A is less than 0. The parabola is
Concave down.
concave down. So we would want to notice, what is A affecting?
The concave.
The concavity. And I want to emphasize, did I say A is the concavity? No. Because A is a value or a number, right? But concavity is concave up or concave down. You cannot say A is the concavity, it just affects the concavity. We need to be aware of that distinction. Because when you look at H and K in a second, or if you already have, H is an important part of the parabola. K is an important part of the parabola. Yes, it affects the parabola, but it also is something important, right? A is just affecting the concavity. Now, I'm going to pause and I want to point this out because I saw some students thinking about this already. All right? When A is greater than 1, the parabola is getting what? More narrow, or skinnier is what a lot of people would say about it. I'm not going to write that out right now because Ms. Courtney is actually working on several lessons to help us understand that better in our next unit. And it looks more narrow, but I want you to hear me very clearly. It's not, it is getting more narrow, but that's going to make you think about left and right. What's actually happening is something vertical. And so we're going to talk about that more within her lesson, okay? And so I will point out, let's say I were to have this point. If I stretch that point up, that's why it looks skinny, okay? And I just want you to be careful about that. So I do want you to notice, like when A was greater than 1, it looked skinny. And when it was between -1 and 1, it looked what? Wider, right? That's the big thing to notice there. But just be aware that we're going to get into more detail about what's actually happening in our next unit. The big thing you need to make sure you have written down in your graphic organizer is this, right? About when it's concave up or down and the fact that A affects the concavity. Okay? Now in this next one, which form of a quadratic equation are we still looking at? We're still looking at vertex form, right? But we're no longer looking at A, we're looking at what? H and K. Pay attention to the next couple of slides to guide your thinking. Slide 5. Considering the features of parabolas, describe how the graph of the parabola changes when the value of H is positive versus the value of H is negative. Same thing with the value of K. Notice in slide 6, I specifically ask you, hey, what values of the equation in vertex form are the coordinates of the vertex, right? So if you were to look at this equation, how would you figure out what the vertex is? Now, I'll go ahead and tell you, these, I think all the way through slide 7, is focusing on H and K. If you answer slide 4 and you move on to slide 5, and you're like, I don't actually know this answer, where could you go to help figure out that answer? Yes, but also you can go back, what I'm trying to emphasize is you could go back to slide 4. So if you answer slide 5, you move on to slide 6, and you're like, I got no clue, go back to slide 4, okay? Work with each other to help each other figure this out. Everything you need is in slide 4 to answer questions 5 through 7. Make sense? Any questions before we get to work? Let's get back to work.
Dividing each side into the parabola on the right side of the equation. And that's the problem. It's negative. Okay,